What's up, guys? Welcome back to another Joe Gaming video. Today we will be reviewing test 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 test. We'll be reviewing the test Joe Gaming. So first problem is this one. Question is limit. Oh no. Oh no. X origin 0 2 minus cube root of x plus 8 over x cubed. So the answer to this question is, well, you have to prove that skibbity and it why so fast? Okay, so first plug in 0 for these values. So we do 2 minus cube root of 0 plus 8, which is 8, over 2 cubed, 0 cubed is 0, and 8 cube root is just 2, so it's equal to 2 minus 2 over 0, which is equal to 0 over 0. And when you're having a limit that is an indeterminate form, which is 0 over 0, you can use L'Hospital, which you have to prove that it's 0 over 0 beforehand, but once you do, you get the derivative of the bottom and the top side to get your limit. So you do d over dx 2 minus x plus 8 over d over dx x cubed, which is equal to the square root, derivative of a constant is 0, and then we have to find the cube root, derivative of negative cube root of x plus 8. So how you're gonna do that is get x plus 8 1/3 derivative, so you do minus 1 and then 1/3 times 1/3. So it'd be like negative 1/3 times x plus 8 to the negative 2/3. Fiend. But since we don't worry about that negative because it's already on the bottom. And since this is a function in a function, you have to times it by the inside function. X plus 8 derivative equals 1, so times 1. It's just the same thing. And then this is over d over dx x cubed. That's just 3x squared. Fiend. And if you simplify this, it would just be negative 1/3 x plus 8 2/3 divided by 3x squared, which would just be times 3x squared, which would equal to negative 1 over oh my god. Okay, so if you plugged in 0 for this, you'd obviously just get negative 1 over 0, right? And when you have a limit, when you have a limit of x approaching 0 and it's over 0, you'd write d and e because it would be negative infinity and infinity. But in this case, since there's a square root, there's a square here and a square here, you know, that would mean that even if you put a negative number in here into the x, if you're approaching 0, you get like negative 0.0001. Even if you put that, it still be positive due to this square. If you put positive 0.00000, it's still positive, right? So therefore, it would be only negative infinity because of this negative sign. If there was a negative sign, it'd be only positive infinity. So the limit of both sides is actually negative infinity. Those who know, and then you'll probably write dm slash dm. Oh, no. Our next question is this right here. Okay, so this problem, limit x to 0 sin x squared plus 2x over x cosine x. Now plug in 0. 0 plus 0 is sin 0 over 0 times cosine 0 is 0, and that's equal to 0 over 0. And since it's indeterminate, we can use Los Hospital. So get the derivative of sin x squared plus 2x, which is cos x squared plus 2x times 2x plus 2 over this is a product rule, so it would be like cosine x plus minus sin x times x. Fiend. And you just get rid of it. And then if you plug in 0, you get cosine 0 times times 2 times x plus 2, which put 0 for 2, 0, you get 0 plus 2. And then over here, cosine 0 minus x 0, 0, so it's just 1 minus 0. And the answer would be 2. Those who know. Bam bam, kira, star. Determine the piecewise function at x equals 1 and x equals 2. Okay, so let's see. Okay, so how do we do this? Well, you just You just gotta see every time there's a x equals or x greater or less than type symbols of a number, which is in this case 1, just plug in 1 for the equations. So we'll plug in 1 for these 3 equations and see what we get. So we got 1 squared plus 2 equals 3. We got 2 equals 2. And we got 6 times 1 squared cubed minus 1 squared minus 2, which is equal to 3. Alright, so it's asking for when it's continuous on the graph, when x equals 1. Now, it's only continuous if the values equal each other. And, well, these are equal, but this isn't equal. And if you look at the conditions here, this is x equals 1, this is x less than 1, and this is 1 greater than x. Notice how these signs don't have a bar under it, signifying that they're not equal. And since this is a 2 and these two are a 3, although these two equations right here and here are equal numerically, their limit approaches the same value, they are not equal or not continuous because the sign, the bar right here, isn't there. And matter of fact, if this 2 was a 3, this entire function at 1 would be continuous, but since it's at 2, it is not continuous because these two other equations are not equal to 2, or this is not equal to these two, which have no bar under it. So therefore at x equals 1, not continuous. Alright, next part is the bottom part. So this one again doesn't have a bar, but it's at 2, x equals 2. So basically same thing as this one, but with with ones. So let's plug into 6 times 2 cubed minus 2 squared minus 2 times 2, 38, and 20 times 2 minus 2. Now that's equal to 38. This is equal to 40. This is equal to 38. No. So we already see off the bat that these two are equal, but this is not equal. So what does that mean? Well, it means that since x is greater than 2, so on the right side it is continuous. The right side of the graph, it is continuous. Since this is not equal, the left side is not continuous. And there is an equal sign here, so you don't need a bar here. But yeah, so basically the answer would be not continuous because these all three of these have to be equal the same value for it to be continuous. So basically limit x approaching to negative side equals limit x approaching to positive side, or the right and left side have to be equal in both limits, and we see that these are not equal, so therefore they are not continuous at all. These three have to be continuous. These two are continuous, but that's only for the right side. What about the left side? The left side has to be continuous. Therefore the answer is x equal to not continuous. Yeah. How much time? No. Fiend. Fiend. Okay. Okay. So we're given a graph, and these are the questions. What is limit x approaching 3 on the left side? F of x. Okay. That's A. So let's look at the graph. 3 on the left side would be here. It's asking for f of x. So f of x, the inside f of x, this one right here. F of 3 from the left side, because we had to plug in x for 3 to the left side, which would be like 2.99. You'd get around -1. It's -1. It was -1. Only on the left side though, because this is the negative left side. And then we had to put f of -1 into the function, into the limit. And so f of negative, 2.99 of f of f, which would equal to f of -1, which would equal to 3. It's equal to 3. The limit of f approaching -1 is equal to 3. So that's the answer for A. The f of 3 equals -1 on the left side. Okay. Next question is, what is the limit of x approaching 3 f of x? So the whole limit approaching 3. Well, it's D and E, because the limit on the left side and the right side do not equal. Because this is the limit on the right side, this is the limit on the left side. There's a jump continuity. It's not. It's just a continuity, discontinuity here. So it don't equal. It's D and E. There's two values the separate limits have, that where the limit of this is not equal. I wrote it right here. Okay. Lim x approaching -1. F of x. Fiend. Okay. So it's asking for f of -1. So let's just put in f of -1. F of -1. Well, we know what that is. It's 3, even on both sides. Look how it approaches at -1 approaches 3 on both sides. Do not make the mistake of thinking that it doesn't approach on both sides. I almost did that. But it approaches 3 on both sides at -1. So f of 3. Well, we see here that there's two values for 3 for the limit. And if you think that it's just f of 3 equals 1 or 1/2, you're wrong, because it's not actually f of 3. It's actually f of oh my. Alright, let's just say, just because there's a black dot here don't mean nothing. It doesn't mean it. Because in actuality, it's actually the limit approaching 2.99. Those who know. Because if you get, since it's a proper limit, it's a full limit, if you plug in 0.99, negative 0.99, or even negative 1.001, you'll still reach at 3, which would equal 2.99999, but not exactly 3. So if you put in f of 2.9, I mean, if you equal of negative 1.00 is equal to f of negative 0.99, because both side limit of negative 1 is equal to 3, it would also equal 3 or 2.9999, but not 3.0001. Notice how there's a dot here, so it would never go over 3. It's signifying it's never going over 3, which is what this limit is. This limit is all the way to 2.9999. This is 3.001 and whatever, so on. So, knowing that this limit will never pass 3, that would mean that it is f of 2.999. I mean, yeah, it's f of 2.999 after you substitute 0.99 for this f of x of negative 1. And we know f of 2.999 from the previous problem, which is just the left limit of 3 is negative 1. You died. Right. What I wrote on my paper was lim x of negative 1 of f of x equals the limit of x approaching 3, or my bad, goes to 3 f of x, and therefore it's equal to negative. Yeah, that's all I wrote. My name is Mike Kwong, and I got a 6 out of 15, 20 billion on the test. Scabbity fish. Oopsies. Yo. Okay. Evaluate the limit. Well, when it says evaluate the limit, just get the derivative of the equation, which you can see the equation right here. So it's tangent x square root x cubed minus 2x. So this is triple chain rule. So the first function is tangent of like u, and u equals like g of x, which is equal to the square root of let's say j, and j equals let's say h of x, which is equal to x cubed minus 2x. So let's get the derivative of the first function. So so it'd be f prime g of x times g prime x, and then g prime x is square root of j. So then it would actually be h of x times h prime x. Yeah, that's how it would be. So f prime x is secant squared of u prime times g prime x, which is, well, the derivative of whole square root is just 1 2 square root x. So it would just be 1, 2 square root j times j prime, which would just be 3x squared minus 2. Ain't it, ain't it, ain't it fiend, 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 fiend. Okay, yeah, so you're almost done with this problem. Just plug in the values of u, plug in the values of j, and you're done. So sec squared u is square root j, and j is equal to cubed plus 2x times 1 over 2 square root x cubed minus 2x times 3x squared minus 2. Yeah, that's the answer right there. You don't need to simplify. It's fine from there. Yep, that is it. I don't want to be nonchalant, try that. No, I want to be a nonchalant. No, I want to be a nonchalant. I'm out of breath. Work out your brain, not your body. Okay. Next question is y equals ln secant of -9 2x minus 3. Now, let's write out the functions. We got an ln u. We got u equals g of x equals u to the -9. Wait, no. Yeah, but let's try it like b of -9. How about that? Yes. And the v is equal to. Wait, I shouldn't have used b. I'll just use j. And then j equals h of x, which equals secant over n. And let's say m of x, or n equals m of x equals 2x minus 3. So there's quadra chain rule. Okay. It's a lot of chain rule. Fiends. Okay. Let's start with ln u. Ln u is just 1. Well, the derivative of ln x equals 1 over x. So, therefore, ln u equals 1 over u. And okay. Times u prime, which is g prime x. This g prime x would just be -9 j to the -10 times j prime. J prime is secant, and secant is secant n. I'm running out of ink, guys. tan n, and then times the derivative of n, and n m of x, which is this, so it's just 2. Baka. Baka. And if we plug in the numbers, we get 1 over u, which is g negative 9. So negative 9 sec next to negative 9 2x minus 3. And since it's on the denominator, at negative 9 turns into a positive. So it's actually positive on the top. So it's sec 9 2x minus 3. Now we plug in j. Negative 9, j is sec 9 2x minus 3. But since the negative is on top, it has to be on the bottom. For, yeah. So negative 9. And then j negative 10. So secant 10 2x minus 3 times 2 times secant n 2x minus 3, blah 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 blah. All that. And then we can cancel, we can cancel these. So then it'd just be negative 9 over secant 2x minus 9 and 3 times 2 times, you know what, I'll just change that to a negative 18 because it's 2 times negative 9. So secant 2x minus 3 times secant, over and if you can see, you can cancel out these secants. So then the answer is equal to negative 18 tan 2x minus 3. Ain't it? Fiend. I think I'm going fat, dude. This one's gonna be a long one too. Oh no. Oh my god. I have AIDS doing this. Okay. 5y minus x times u to the xy squared equal to. We get the derivative. Derivative of a constant equals 0. Let's get the derivative of 5y, and I mean dy dx of it. Wait, let me see. Yeah. Dy dx. Okay, so how do we get dy dx of 5y? Well, typically 5 to the x of dy dx would equal ln 5 times 5 to the x, right? Well, that is the case for this one. If we replace it with a y, it would just be 5y times ln 5. But since this is a y, not an x, it would just be dy dx. Because the x's, if it was an x, they would just cancel out. But they don't cancel out because of the dy dx. And then negative all that. There is product rule. 2 product rules. There are literally 2 product rules. And then there's implicit differentiation. So let's write this out. So we got negative times, and let's just say xy squared equals u. So the derivative of negative x to e to the u, which is equal to e to the u times x times e to the u but e to the u derivative. Oh my god. Wait, no, this is a plus, by the way. It's a plus. Times e to the e to the e to the. Alright, so first there's a chain rule. E to xy squared. There's a chain rule. So it's x y squared times e to the xy squared, because due to chain rule, e to the anything is just e to the anything multiplied by the derivative of x to y, so d over dx of this. Oh my god. Okay, let's get it. So chain product rule, x, so it's just y squared plus x times 2y times dy dx, and that's times, that's being multiplied by e to the x y blah, 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 blah. Blah, 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 blah. And you know what, let's just have e to the x with it too. At that point, let's just get rid of this. So e to xy squared times x times all that equals e to xy squared. Wait, no, that's a yes. Okay, no, not yet. X to yx y squared x plus e to xy squared x squared 2y. That's right, 2. Wait, where am I? Where am I? Where am I? Oh. Oh my god. So now it's 5y times ln 5 times dy dx minus e to the x y squared plus e x on the minus, it's a minus, minus 2. Dude, I'm about to get brain damage. Let me see. Oh my god. Okay, so man. Oh my god, man. Okay, so let's just move everything that doesn't have a dy dx to the right side of the equation. So which ones are they? There's this one. There's just these two. So let's move them to the other side. That's just exy squared plus y squared x e xy squared. And what we have left is on the other side, 5y ln 5 dy dx minus 2 e dxy squared x squared y dy dx. Yeah. And we just factor out dy dx. So we just get dy dx. So we go to 5 times ln 5 minus 2 to x y squared x squared y. It's equal to that. And we just divide this. So dy dx equals dx y squared plus y squared x exy squared over 5y ln 5 minus 2 e x y squared x squared y. Holy moly. B. Is that what I got? I swear if I got it wrong. xy squared plus xy. Okay, yes. 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 I think that's about right. Yeah, that's about right. It's gotta be right. Let me just check the paper I have. Okay, xy, xy. That's what I got. Right. First try, holy moly. Oh. New prime. Okay. Next question. Which of the following are true? An equation for the tangent line of the graph of a differential function f is okay, so at f of 2 the tangent line is y equals 9x minus 12. Okay, indicate whether of the following statements are true or false. Explain your choices. Okay. F of 0 is negative 12. Fway. Now, there is no, this is false because it is not necessarily that it has to be negative 12. In fact, yeah. If it was negative 12, then it's tangent on 2 points of f, which shouldn't be true because you're getting a tangent line of only 1 point, not 2 points. I think. Wait. Yeah. So basically, what it's saying is okay. So this negative 12 here on this equation is basically its y-intercept, and let's just say we have a random. Let's just say we have a random equation like this. Like this. This is not the equation, but let's just say it most likely is a cubic. I mean, quadratic. And at negative 12, so it should be more like here. So it's saying that at 2, which is right here. Wait, not tripping balls. Hold on. Oh my god. So at negative 12, look around, at 0, it's the y-intercept. Okay, and at 2, which could be like right here, it's saying that not only does this f of x graph at 0 is negative 12, but this line is at negative 12. So it's basically saying that it's tangent for both sides. These 2 points on the graph and one line is tangent to both of them. which is, I mean, it's probably false. I've never heard of this before. So it's false because it's tangent to 2 points, which shouldn't, like, that shouldn't be true. Like, how is it tangent to, like, it really can't be tangent to 2 points on one line. One tangent line cannot be tangent to 2 points at once. It can only be tangent to that one specific point, which in this case is x equals 2. That's why it is false. Okay, f of 2 equals 6. And that is true. F prime, wait, no, that's just f2. Okay, it's just f of 2 equals 6. And it's true because of this. Y minus y1 equals m times x minus x1. Now, the equation you're given is not in this format. And in order to get to this format, well, we need to get what x1 is and m. And we do know what those values are. M is 9 and x1 is 2. So let's plug in our nodes. Okay. Now, to solve for y1, just basically, so just do y, so it's equal to 9x minus 18. Yes. Okay. Now, you may be asking what you must do. So after this, so we just plug in. Okay. Just plug in y. So 9x minus 4 for y is a system equation. So 9x minus 12. These 9x's cancel out. Plus 18 on this side. Y1 equals 6. And did you know that y1 is equal to f of whatever the f of x1? So, and 2 is x. Yeah, there you go. There you go. There you go. Those who know. Oh. Okay, f of prime 2 equals 9. That's easily verifiable. 9. Okay, so tangent line f of prime x equals to m of the y1 minus whatever equation. And since there's a 9 right here, it is true. So no need to explain that one. It's easy. Okay. Next equation. Oh no. Oh no, no. Oh no. Oh no. That's easy to read. Alright. So we're given an equation that's parallel to the tangent line of the curve x squared plus y squared equals 20. I instantly turn this into a readable equation. 2x plus 7 equals 4y. Okay, so y equals 1/2 x plus 7 over 4. So that's off the bat. Then there's implicit differentiation for this. X squared plus y squared equals 20. So x squared plus y squared equals 20. constants equals 0. Power rule 2x plus 2y dy dx. And then if we solve for dy dx, we get negative x over y. Also, get rid of those two. We can get rid of those two. Minus x to here. Divide by y. So you get that. Green. Line equation to the normal out of the curve. Normal line is perpendicular, and perpendicular of any equation is the negative reciprocal. The m equals negative reciprocal. So that would mean that the normal line would have to equal negative 2x. Yeah. But that's for later. So, how do we solve this? Well, since we're giving a parallel lines means that their slopes are equal. So that means dy dx equals 1/2 equals negative x over y. And to solve for one of them, I'm gonna solve for let's solve for y. So so x squared plus y, I'll just even solve for it. It would just equal square root of 20 minus y squared. Those who know will know. Okay. So once you're given that, you plug in x for that. So 1/2, or you know what? I'll multiply y on this side. So y over 2 equals negative square root 20 minus y squared. And if you square that, if you square the whole equation, you get and also that negative disappears because squaring things gets rid of the negative. So yeah. And then times 4 on this side, it's 80 minus 4y squared equals y squared plus 4y on this side equal 5y squared equals 80. And then divide by 5. 80 divided by 5 is 16. So y squared equals 16. And if you square root it, y equals plus or minus 4. Okay. Now all you have to do is go back to Hak2. Okay, you know. And then let's go back to the equation of y over 2 equals x. And we'll plug in plus or minus 4. So negative 4 over 2 equals negative. Well, I'm not negative. Yeah. Put a negative there because it's still a negative. So negative 4 over 2 negative equals 2, and positive 4 over 2 is negative 2. Yeah. So that would mean that negative 2 and positive 4 and 2 and negative 4 when you plug y or plus or minus 4 into this. And then so basically this is x1, this is y1, x2, or yeah, there's like, and like I said earlier, that the tangent line equation would be something like this. right? Well, um, well, this is a tangent line equation. Well, normal line equation would be 1 over f. It's a negative f prime x1 times x minus x1. So basically, we know it's 1/2, and so it's -2 times x minus, let's use this one, x plus 2 equals y minus 4, and another equation is y plus 4 equals -2 x minus 2. These are the answers. Oh my god. What have you done to me, Matt? You've done this. It was all your fault. I ain't done yet, man. Almost done. Okay, I got an algebra mistake on this question, so let's see if I can fix that. Frame. Okay. Oil is spilling out of a cone. Cone. And there's like oil spilling out. Okay. At a rate of 28 pi. So basically, the V is decreasing. Wait. Yeah, flowing is decreasing at -28 pi. At the very instant, the height, so when it is pouring out at -28 blah blah blah, the very instant the height, wait, no, okay, so what, at the moment that the height of the oil, so let's say the oil is at here, which is 4, the radius, or I mean diameter, so across is 6. So that would mean the radius is 3, because diameter is radius times 2. At what rate? At what rate? At what rate? At what rate? Wait, hold on. At what rate? Can name rate? Hold on. Okay, so so we're solving for the, oh wait, my bad, this is dh over dt, dv over dt. So what we're trying to find is dh over dt. So let's set up equation. V equals 1/3, wait, what's the volume of cone? Alright, so yeah, it's 1/3 pi r squared h. And to get the derivative, it would be dv over dt equals pi 3 2r dr dt times dh dt. We do not know two of these, so what we're gonna do instead of that is find how much of how much of R is H? So we're given a ratio. So R over H equals 3 over 4. That means R equals 3 over 4H. And if we plug it back into this equation, it'd be V equals pi 3 times 3 over 4 H squared times H, which is V equals pi over, it'd be like pi over 16 H squared, and no. Remember, 3 times pi over 16 H cubed. So, with that new information, let's fix this to be 3 pi 16 times 3h squared dh dt. Fiend. Okay. Way. Okay. So, if we simplified it, what do you go to? 9 pi. Actually, you know what? We'll plug in h right now. H is 4, which is 16. And 16 divided by 16 cancels out. So, now we just have 9 pi equals 28 pi dh dt. Okay, something is wrong here. So tired. Hamza. I mean, 28 over 9 is dht, but I'm pretty sure it's something else. Something's wrong here. I can tell. Maybe it's the negative, that's what I got. Wait. Am I fiending for more or what? Hold on. Okay guys, what's 9 divided by 48? No shit, freaking man. 3 over 6. That's what I wrote. Times 3 H times 3h squared. So that's 9. That's 9 6 times h squared 16 equals 8 pi. Wait. Fue. I don't know, man. I don't know. It could be 28 over 9. Who knows? Maybe I'm tripping balls. Who knows? Who knows? Anyways, regardless if it was negative 28 over 3. I just want to feed. I just want to feed. Hey Drake, I heard him young. I'm down to take myself black one. Yeah. Wait a minute. Fue. A diamond mine cart, 90 feet long, 35 feet per second. I did this the last video. So let's draw it out. So we got a square diamond thing. You know, those you know. So we got that. And 90 feet long. And some person is 10 feet away from the third base. So would be like around 10 feet. And it's asking the rate of change of the angle. The angle. So how do we find that? Well, use what we're given. Also 35 feet this way. So we don't even need this hypotenuse. Really. I mean, we kind of do for the angle, to know the angle, but like, we don't need the number, the length of this. Alright. So, what it's asking for is d theta over t when given, let's say this is y, this is x, when dy dt equals negative 35 feet per second. So, let's get it. So, how do we get d theta? Well, there is an equation that relates to these two sides, which is tangent theta equals y over x. Is that right? Who knows? And then since x is a constant, we can just plug that in. You can plug in the constant. Actually, you know what? Actually, it's fine. This is very fine. Yeah. Okay. So 1 over 90 times y equals tan theta, and we get the derivative. So we get d theta over t times sec squared theta equals, well, that's just dy dt times 1 over 90, and then we divide it by sec squared theta the other side, and we'll get yeah, we'll get 190 sec squared theta over, and then times dy dt, which is 35, so it's like 35 on top, equals d theta over dt, and to find sec is 1 over cosine theta. Oh wait, maybe you do need the, okay, yeah, you probably do. Well, cos theta equals hypotenuse for this angle would be x. So yeah, after that, what you're gonna do is find the hypotenuse, which is square root 8200. Those who know will know that it's the hypotenuse. Just name. 10 squared plus 90 squared square rooted is equal to that. So I'm saying. Okay. So given that, that would mean sec is equal to h over x, which is square root 8200 over 90 Bean. Okay, and if you square it, because it's sec squared, sec squared, it equal like 8200 over 8100 times 90, by the way. And since this is a 90 squared, it would be 90 over 8200 over 35. There's a lot to do. So it's 35 times 90 over 8200. I can either simplify this, whatever, but you get the point. It's this. Oh wait, rad per second. Rad per second. Cause yes. No. Yes. No.